Hi, welcome to Deep Learning Talks. So today we are going to talk about tokens and token embeddings. I have seen a lot of people struggle with the idea of token embeddings whenever they are studying transformers. They always confuse token embeddings with something that token embedding is not. So let's first talk about what really happens and how does the workflow of the whole input to a transformer looks like. The first thing that we see is always a text, right? Let's say now text is nothing but bunch of words, millions and billions of words. Now we have something known as tokenizer that tokenizes the text. What I mean by tokenizes the text means that it converts the whole words into tokens. Now what are tokens? For example, just imagine that puru is a token, right? We are not directly saying that each word is a token. Tokenization is another process that gives rise or birth to tokens. Now in some categories, in some examples, we can have one word as one token, but generally we use tokenization algorithms like byte pair encoding, BPE algorithm, that tokenizes the whole text. What I mean by tokenizes means it breaks down the whole text into a series of tokens. Every token has a token ID. Now, for example, Puru Kathuria, let's say Puru is one token, KATH is one token, URIA is one token, right? Puru Kathuria can have three tokens. Space is also included in tokens, and special characters, any form of character, are included in tokens. So, in our case, Puru space is one token. Now, Puru space will have a token ID, right? Now, what is token ID? Token ID is a discrete ID. It's not a continuous ID, it's a discrete ID. For example, maybe 1024, 1058, depending on the algorithm. The algorithm will assign every token an ID. The algorithm will see a bunch of words and it will assign every token a token ID. Now, token ID is not token embeddings. Tokens are not token embeddings. Tokens are not always words. They can be subwords. There are different algorithms that converts the words into tokens, but not every token is a word. Not every word is a token, right? So we can have subwords categorized as tokens. We can have one word categorized as a token, right? So token is basically a statistical unit that is produced by a statistical unit that is learned from your data, and that is produced by the tokenization algorithm, right? So what we mean to say is, before you run the whole transformer algorithm or before you feed anything to the transformer architecture, you first run tokenization algorithm. Now, who writes this tokenization algorithm? You as an engineer are going to write, or the production grade LLMs generally use byte pair encoding tokenization algorithm. You can use one such algorithm, right? So sometimes for explanation, for sake of simplicity, people assume that one token is one word, right? So now we know that we are dealing with we were dealing with a lot of text of based, text that constituted of words. Now we are dealing with a lot of tokens, and every token has a token ID, right? And token ID is numerical, token ID is discrete. Now, what the hell is token embeddings? Now, just imagine we had a tokenization algorithm that produced a lot of token IDs and that produced a lot of tokens. Now, tokenization algorithm itself, is a piece of art, and it learns what all tokens to produce from your data. When I say it learns, I don't mean that it learns using the weights and biases. It's a trainable algorithm. No, right? Now, when you have produced token IDs, think of token IDs as hash IDs. They are unique in nature, and for the whole vocabulary, you will have token IDs. Now, every token, for example, let's take Puru into consideration. Puru can be expressed as an embedding vector. Puru can be expressed as a vector, right? Puru can be expressed as a one-dimensional vector, as a two-dimensional vector, as a three-dimensional vector, or as a 512-dimensional vector. Every vector has direction and magnitude. Let's say that we want to express Puru in very high dimensions. Puru is a data point in 512 dimension universe, right? What that means is Puru is going to be expressed as a column vector of 512 dimension, right? Now this is known as embedding, right? Embedding of a token or token embedding simply translates that the what is the meaning of the token. It tries to encapsulate what does the token really mean. It does not, translate into a discrete number. That is token ID, right? And it is not text. That is token, right? So token embedding is a 512 dimension vector. How do you produce this 512 dimension vector? When we are dealing with transformers, especially the production grade LLMs, these token embeddings are trainable. What I mean by that is we start with some random token embeddings for every token. And when the algorithm goes under training, when we do gradient descent, when we find the optimal parameters, these token embeddings get trained themselves, right? Let's imagine if Puru is a 512 dimension embedding. What I basically mean by that is Puru is a data point in a 512 dimension universe, right? But if Puru was only a one dimensional embedding, then Puru would have been a data point or a number line. If Puru would have been a two dimensional embedding, then I would have been a single point, P1, P2 on a two dimensional plane, right? Here I'm a data point in 512 dimension universe, right? Now we have established that all the tokens can have their embeddings that translate into the meaning of the token, and it helps the algorithm understand what is the meaning of the token. We have also established that token embeddings are going to be trainable, especially for transformers. What we can infer from this particular fact that we are not using a static algorithm that is producing all the embeddings, then we use the embeddings. We don't have any word to vectorize algorithm that will vectorize or produce embeddings for all of our data set, and then we will feed it to transformer. No. So when we say that all the token embeddings are trainable, what we mean is if Puru is expressed as 512 dimension, all the 512 elements are going to be updated and learned, and because the embedding itself is learnable, right? What that also means is, let's say we are dealing with a million sized vocabulary. 1 million cross 512, let's say we have 1 million tokens, and we every token is 512 dimension. That means 1 million cross 512 elements, which is 512 million elements, are going to be updated, are going to be learnt throughout the algorithm, right? So in case of transformers, token embeddings are something which is known as trainable vectors, right? And they are not static. So let's imagine that we produce the first algo. What the first algo does is, the first algo takes in a lot of text, a lot of paragraph, a lot of text documents. It produces tokens, right? That's the first algo. When and it produces tokens. That's the first algo. Now, once it has produced tokens and token IDs, then we feed it to the transformer, and the transformer uses something known as token embeddings, which start generally with a random set of embeddings, and then we'll over time learn, and then we establish the semantic similarity, the geometric representation, and the alignment of vectors. For example, bank and cash would align in some universe, and Eiffel and tower would align in some universe when the transformer tries to understand and build statistical representation of the whole vocabulary set. So when this embeddings go into the transformer, I mean, before it goes into the transformer, there's also one special set of embeddings that gets added with these token embeddings, which are known as positional embeddings. So this is true for transformers. Transformers need to understand the relative order and the relative positioning of all of these tokens with respect to each other, right? Since it's relative, and transformer cannot do subtraction in real time. A transformer is a neural network. Transformer does not know how to do subtraction. It cannot calculate the position of Kathuria with respect to Puru, right? Since it does not do subtractions, and we don't really want to have discrete token or position embeddings for all of these tokens, right? So what the problem that we are dealing with is, we had 1 million tokens. The meaning of the token is encapsulated, is expressed through token embeddings. But what about the positions? We want the ability to express positions. The transformers does not really know how to calculate relative positions because it does not do subtraction. We cannot have discrete positional embeddings. We cannot have discrete positional IDs, right? I cannot say 0, 1, 2, 3, 4, 5, 6, 7, 8. I cannot have a sequence counter that assigns position IDs to each of the token, right? Because if I do that, I will not be able to, first thing is, add it to my position embedding to have a meaningful information set. Second thing is, I will not be able to ask my transformer to compute the relative positions, right, with respect to each other. We need an idea where we, add some positional information into the token embedding space. And the main idea is that we need those positional embeddings can also be trainable, right? And if they are not trainable, we can use sine and cosine waves to produce positional embeddings. And the positional embeddings are also going to be of the same size of token embeddings. So we have token embeddings that express the meaning, we have position embeddings that express the positions, and we add this information. This is what goes into the transformer. Some architectures, some research based architectures like attention is all you need, they use static positional embeddings. They use sine and cosine waves to simulate the position IDs, and they are also continuous in nature, they are not discrete. Some architectures like the GPT family, they use trainable positional embeddings, right? So I think now the meaning should be clear in itself. Token IDs are something which is different. They are produced by a tokenization algorithm. The most famous one is byte pair encoding, and tokens are completely different. Token embeddings are completely different. Positional embeddings, positional IDs is not a thing. Positional embeddings are also completely different, right? I think that's it for now. Thank you.